This is part 2 of 2.4. I'll be looking at some more examples of chain rule. I'm looking at some more complicated problems. So here's example 4. Now in this function, it's going to be a product. So in order to find my derivative, I have to use the product rule. So y prime is going to equal. You can think of this whole quantity that's being squared as the f portion for the product rule. All this cosine expression is going to be the g part of the product rule. So product rule says keep the f the same, so it's going to be quantity 1 minus 4x squared. Multiply that by the derivative of cosine. Now inside cosine I have x over 3, so I have to use the chain rule. So the outermost piece is going to be the cosine, so the derivative of that is negative sign. Chain rule says keep that the same, so I'm going to leave the x over 3 the same. Then I have to multiply by the derivative of the inside being x over 3. So over here on the side, let me find the derivative of, well, x over 3 is the same thing as 1/3 x. So I can just say this derivative is going to be 1 over 3, 1x to the 0, which is just going to be 1/3. So the derivative of x over 3 is going to be 1/3. Alright, so all this is just the first part of the product rule. So now I have to do a plus, keep the cosine expression the same, so cosine x over 3, and now I have to multiply that by the derivative of this. Again, this is a chain rule because I'm raising something to an exponent, and I have 1 minus 4x inside. So the outermost is the power rule, so I drop the 2 in front, keep my parentheses, subtract the power by 1, keep the inside the same, so it's going to be 1 minus 4x. Now I have to do the derivative of the inside part. So let me see if I can find some room over here. The derivative of the inside of 1 minus 4x. Well, the derivative of a constant, which is 1, is going to be 0. The derivative of this is going to be negative 4x to the 0. So the derivative of this piece is negative 4. Alright, now it's just a matter of simplifying all this. The first part I have a negative sign and I have a 1/3, so I can multiply these two together to get negative 1/3. Then I'm just going to put 1 minus 4x quantity squared and then sine of x over 3. The next piece I'm multiplying a 2 and a negative 4 together, so it's going to be negative 8. And then I'm just going to pull this 1 minus 4x in front of the cosine. And then it's going to be times cosine of x over 3. And this bizarre looking expression is in fact the derivative to what we were given. Alright, next example. Looks innocent enough, and all I have to do is use the chain rule, and we'll see what happens when I use the chain rule. Alright, chain rule says do the derivative of the outermost. In this case, they're asking for dy dx. So dy dx. The outermost is raising something to the 4th power, so I'm going to do dropping the 4 in front, recopy my parentheses, subtract the power by 1. The inside stays the same, so it's going to be x minus 3, x plus 5 in the denominator. But then when I do the derivative of the inside, this is going to require the quotient rule. So all of this is going to get multiplied by the derivative of this, which requires the quotient rule. So this derivative is going to be down z, x plus 5, times up c prime, so the numerator, the derivative of that is going to be a 1, minus up c, so x minus 3. the derivative of the denominator squared, or the derivative of the denominator, sorry, which is going to be a 1. I'm going to hit myself. All over the denominator squared, x plus 5 quantity squared. Alright. Now all I can do is really simplify this expression. This is going to be left alone. So I'm going to multiply this together, or distribute the negative, so it's going to be x plus 5 minus x plus 3 all over quantity x plus 5 squared, and recopy this x minus 3, x plus 5 quantity cubed, multiply that by 4, and notice I have a positive x and a negative x, so that's going to cancel out. I have a 5 and a 3, so that's going to give me 8. 8 for the numerator is going to be x plus 5 squared. It's going to be x minus 3, x plus 5 quantity cubed, multiply that by 4. I guess the last thing I can do is I can multiply this 4 with 8 to give me 32. And because I'm raising each individual term to the third power, I can do x minus 3 quantity cubed all over x plus 5 quantity cubed. And because I multiplied this 4 and the 8, all I have left over down over here is 1. This is going to be x plus 5 squared. I have the exact same base. When I multiply and I add bases, so this just turns into 32 x minus 3 cubed all over x plus 5 to the 5th power. Because I'm multiplying these two, when I multiply, I have the same base. I add the exponent, so it turns into the 5th power. And let me just draw write my 3's a little more clear. So these were both individually raised to the 3rd power, because I was able to simplify. And this is what my derivative with respect to x turns into. And that's all for part 2.